All right, today we're going to be measuring angles and arcs. Measuring angles and arcs. And first thing we're going to do is define a central angle. A central angle of a circle has a vertex at the center and contains two radii. And a central angle, it looks something like this. This angle here, ABC, that's a central angle. All right, then we're going to say that the sum of the measures of the central angles of a circle is 360 degrees. Meaning if you've got this central angle ABC, and then if you were to add another radius right here, call this point D, you've now got three angles inside of this circle. All right, the sum of these three angles, if I numbered these 1, 2, and 3, angle 1, angle 2, and angle 3 over here, angle 1 plus angle 2 plus angle 3 has to equal 360 degrees. All right, so you'll have some practice problems today where you're going to be asked to find the value of x. And you'll be given a circle. And then inside that circle, you'll be given some different angle measures. Where's the red? All right, so if you're given this picture and you got to find the value of x, all right, well, x is going to be equal to 360 minus 130 minus this 90-degree angle. So 360 minus 130 minus 90. 140 degrees. So the measure of angle X in that case would be 140 degrees. An arc is a portion of a circle. Defined by endpoints. And its measure is the same as its corresponding central angle. An arc is a portion of a circle defined by endpoints, and its measure is the same as its corresponding central angle. So if you've got a circle, and that circle has a central angle here, ABC. All right, this portion of the circle right here, the blue portion of the circle, that's called an arc. And here's your symbol for arc. This would be called arc AC. All right, the blue arc there. And arc AC is equal to the measure of angle ABC. So if angle ABC was 88 degrees, then the measure of arc AC would be equal to 88 degrees. If we added another central angle here, and you were told that this arc DC starts at D and it goes to C, and it's along the circle. And if you were told that that arc measure was 120 degrees, and you were asked to find the measure of angle DBC, all right, which is the measure of its corresponding central angle, the measure of angle D, starting at D, with B as a vertex and back over here to C, would be the same as its corresponding arc. So this angle measure would be 120 degrees. All right, so they go with each other. They work hand in hand. If the arc's 120, then its central angle is also 120. If a central angle is 88 degrees, then its corresponding arc on the circle is also 88 degrees. Everybody okay with that? All right. Now, you've got a couple of different arcs. You've got a minor arc. That's the shortest arc. Connecting endpoints. Here's what I mean. if you've got a circle and you've got a central angle, right now, there's two arcs in this picture. You've got an arc that goes from A right to C. Shortest arc. Okay? That's a minor arc. There's another arc in this picture. The other arc in this picture starts at A, it ends at C, but it goes through D. Okay? So if you can picture this arc, it starts at A, it goes around the back of the circle now, or the left side of the circle, through D, and it ends at C. That's called a major arc. That's the longest arc connecting endpoints. Now, when you're describing these two arcs and the way that you describe them to keep them different from each other, this minor arc would be described as arc AC. That means start at A, go directly to C, the minor arc. This major arc, if you were going to describe this major arc, you would describe it as arc A DC. That means you're going to start at A. You're still going to end at C, but you're not going to go directly. You're going to go through D. So that means you have to go the long way around the circle. All right? So when you're describing major arcs, you're going to be using three letters. Starting point, end point, and the point that you're going through to get from the beginning to the end. When you're describing minor arcs, the shortest possible arc, you're just using two letters. The beginning and the end. All right, third type of arc is called a semicircle. Semicircle is an arc with end points on the diameter. All right, it's got end points on the diameter. And hopefully by this stage of your mathematical career, you know what a semicircle is. All right, you've got two arcs here. You've got arc AB and you've got arc ACB. All right, so we're just talking right now about arc AB. It's a semicircle. Its endpoints are on this diameter. All right, so second part of your assignment today is you're going to be identifying major arcs and minor arcs, and then you're going to be asked to find their measures. So in this picture, we're told that GJ, segment GJ, is a diameter. Identify each arc. then find its measure. So we've got a circle here. Here is our GJ. The center is at K, and this radius here is KH. And this angle GKH is 122 degrees. So the first thing that you're asked to find is the measure of arc GH. Arc GH has a corresponding central angle that measures 122 degrees. So GH is going to measure 122 degrees. And it's a minor arc. The measure of arc GLH. All right, we need GLH. So look what you got here. You're starting at G. You're going through L and ending at H. So we go G through L, ending at H. So there's a couple different ways to find this arc measure. Number one is you can take 360 and subtract 122. Okay? And 360 minus the 122 is 238 degrees. Because this green arc has two corresponding central angles. It's got this semicircle that measures 180 degrees. And it's got this other minor or other central angle that measures the difference between 180 and 122. And that's 58 degrees. All right, so this 180 plus the 58, that sums your 238. So those are the two different ways that you can find that arc measure. All right, and that's a major arc. All right, in this picture, PM is the diameter, segment PM. Identify and find each measure. All right, so here's the circle. Oof. Here's your PM. Sometimes these problems are actually simpler to just fill in all the information that you can right before you even look at the question. Here's some of the things you can do. If P to M is a diameter, all right, then M, this is R in the middle here, point R. I'm sorry, this is R. This over here on the left should have been an N. So make that an N. All right, some of the things you can do, like I said, is you can start filling in all this information. If this angle PRQ is 115, then arc PQ is also 115. If this central angle PRN is 90, then its corresponding arc is also 90. My drawing isn't very good, but if P to M is a diameter, and one of these angles is 90, isn't the other angle 90? Which makes arc NM 90. And if angle PRQ is 115, and you take 180 and you subtract 115, you're left with 65 degrees right here, which makes arc PQ 65 degrees. And that's pretty simple work to do in advance, and it doesn't take very long. And now you have all the information you need to answer any question about this circle. So they ask for arc MQ. M to Q. It's right here. Done. 65 degrees. 65 degrees, and it's minor. MNP. Arc. MNP. Some blue. MNP. Oh, right there. That's a tough one. MNP. That's 180, right? That's a semicircle. MNQ. Arc. MNQ. M. N. That's a big one right there, isn't it? See it? That means you got to start at M. You got to go through N. So we got to go M through N and all the way around here to Q. N to Q. That's going to be your 360 minus the 65, right? So 295 degrees. And that's a major arc. Everybody okay with that? Good. Very good. Now, let's say that you're given like this pie graph. That's bad. Pretend those connect. Here. Here. Go A, B, C, D. You're given this, let's say it's a pie graph and it represents, some different information. All right, so we go 360. And let's say that, that'd be like 45%, 10%. so I got 40. All right, so let's say you got your pie graph, and it represents some data, okay? Whatever the data is. And now you're asked to find the measure of each arc. Now, just be careful here, because look, let's say you got to find the measure of arc AB. If this arc AB, right here, its corresponding central angle, you see how its corresponding central angle is listed as a percentage? Its corresponding central angle is listed as 30%. Well, isn't that 30% of 360? Okay, because all of these central angles represent 100% of 360. And if arc AB represents 30% of 360, well, you take 0.3 or 0.30 and you multiply it by 360. And 0.3 times 360 equals 108 degrees. Make sense? All right, if you need arc DC, arc DC has a corresponding central angle that represents 45% of 360. So its arc will represent 45% of 360. So we go 0.45 times 360. And that's 162 degrees. Get the idea? All right, whether it's a minor arc or a major arc, convert the percentages to a angle measure in relation to 360 degrees. Because these all would sum 100% of 360 degrees. All right, and then I think we might do arc length tomorrow. We're just going to do arc length today. All right, arc length. Is the distance of an arc. It is found by using the following. So we're going to say that the length of an arc is equal to x over 360 times 2 pi r. Arc length. Bless you. So let's say we got this picture here. And here's our radius. The length of this arc, right here, arc AC, the length of that arc, your arc length, is equal to your central angle measure divided by 360 times 2 times pi times r, r being the radius. Okay? So if we put some numbers in here, and we say that x degrees, let's say that this is 92 degrees, and this radius is equal to 8, then the length of the arc, of arc AC is going to be equal to 92 divided by 360 times 2 times pi times 8.